Okay, once again we're back from the break, and what we're going to talk about here is the inverter design layout. It's very simplified, but it is similar to your assignment number 1. So basically you're going to start with a silicon substrate. In this particular case it's going to be p-type. So our n-type transistor is going to sit in around here, and we have to create a region for the p-type transistor to sit, so we create an n-well over here. The details on the left sort of tell you some of the processing details that we require to make those regions. At this point in time, a thin oxide layer region is cut out of the field oxide, and then this thin layer is deposited across here. The polysilicon gates are then deposited on top of these, and these would be done by a process where the entire wafer would be covered with silicon, and these would be masked off, and perhaps the remaining regions etched away. And you'd end up with a pattern that looks something like that. Sort of after the polysilicon, then you make the transistors N and P type. So this is a heavily implanted N type region. This is protected during that point in time, and when this is being implanted P type, this whole area is protected, and this area here gets goes through an ion implantation stage where the material becomes p-type. So then the left-hand side just again talks about some of the technical details if you're interested in the actual processing. At this point in time, a thick oxide layer is deposited over the entire wafer, and then some contact vias are essentially cut out in a chemical manner so that you are able to contact the polysilicon layer and the source and drain of the individual transistors. At that point in time, you can deposit a metal layer. So this is showing a metal one that has a ground rail and a VDD rail, and then the drains of the transistors are connected by metal through those vias that were patterned previously, and the gates are tied together again through those vias which were deposited previously. So you can sort of tell that an inverter is sort of taking shape here if you look at our old friend the inverter. At this point in time, you might want to have some routing wires, which are again metal layers, and modern processes of many metal layers. So in this particular case, this sort of shows that you've created a via on this dark blue metal, and you've deposited another piece of metal on top, which would be the input to that inverter. Similarly here, you've created a via to get through to the lower level metal, and you've come out on metal 2, and that's the V out, or the output of the inverter. Here's sort of the process in I wouldn't call it an animation, but something. So you're starting with the well and the substrate. The thin oxide layers are patterned. The polysilicon gates are put down on top of that, and then the source and drain regions of both transistors are ion implanted, respectively N and P type. At that point in time, thick oxide is placed over the entire integrated circuit, and then contact cuts or vias are created. So these allow you to go down and contact, let's say, the source regions of the transistors, or the drain regions of the transistors, or the polysilicon of the gates. At that point in time, metal layer then, depending how you want it connected up, are patterned and placed. So this would have been our ground rail, our VDD rail. This ties the gates together, and this ties the outputs together. And then, as we saw previously, some more contact cuts are created, and another level of metal goes on top to allow you to have an input to the device on metal 2 and an output on metal 2, and then that's basically our inverter. If you looked at a cross section of it right at this particular point here, you'd see something that looked like this. I tried to line them up a little bit, where you have one transistor down here. You have the output tied together, so it's common drains, and then the other transistor sitting here. So this was the p-type transistor, and this was the n-type transistor. And that's it for that section.